Rolle's theorem. Okay. Now, what the theorem says is that let's say we have a function f of x, which is continuous in the interval a to b, in the closed interval a to b, and is differentiable on the open interval a comma b. And f of a is equal to f of. So here, if you notice, e is equal to f of a, let's say, and f is equal to f of b. So here you notice that e and f, they are at the same value of y. So f of a is equal to f of b. If that is the case, if all the three conditions are satisfied, then there must be at least one value c such that the tangent at that point is horizontal, right? So which means what? Tangent, when we say, we are talking of the slope equal to 0. So f prime of c equal to 0. Okay, now let's actually solve some problems based on this. So first one, let's say we have a function y is equal to x square plus 1, and we are told that we have to look at a closed interval of -1, 1. Okay, so this is going to be, this is a quadratic equation, so it is going to be continuous. More than a quadratic, it's a polynomial. So polynomial, therefore continuous in the closed interval -1, 1, and it is going to be differentiable in the open interval -1, 1. Okay, now the third condition is f of a and f of b should be equal. So here f of a is nothing but f of -1, and f of -1 is -1 square plus 1, which is 1 plus 1, which is 2. Similarly, f of b is going to be f of 1, which is equal to 1 square plus 1, which is 2. So f of a is equal to f of b. Since all the three conditions are satisfied, what the theorem says is that there must be a point. That means there exists a point C belonging to open interval -1, 1, such that f prime of C is equal to 0. That means the tangent at point C is horizontal. The slope is 0. So let's see. F prime of C is going to be, remember the function is x square plus 1. So 2c plus 0, which is 2c. And this should be equal to 0. So equal to 0, which implies c is equal to 0. So that means that c is equal to 0, the tangent is horizontal. That means it is a point at which the curve changes direction. Now let's look at the second problem. Y is equal to minus x cube plus 2x square plus x minus 1 in the closed interval -1, 2. Okay, it's a polynomial. Since it is a polynomial, it is continuous in the closed interval -1, 2. It is differentiable in the open interval -1, 2. And now we have to figure out f of a, which is f of -1, which is going to be equal to -1 cube plus 2 -1 square -1 -1, which gives us -1 cube is -1, so minus plus, so 1. This is going to be 2 -1 -1, which gives us 3 minus 2 is 1. Okay, now let's look at f of b, which is f of 2, which is going to be -2 cube plus 2 times 2 square plus 2 minus 1, which gives us -8 plus 8 plus 2 minus 1, which gives us 2 minus 1, 1. So here f of a is equal to f of b, the third condition is also satisfied. So therefore there exists a point C belonging to the open interval -1, 2 such that f prime of C is equal to 0. So f prime of C is going to be what? So wherever x is there, we just write C, but we need to differentiate it. So our function is minus x cube. So minus 3c square plus 4c plus 1 minus 0 equal to 0. So which implies minus 3c square plus 4c plus 1 equal to 0. Now let's multiply it by minus 1. So we get 3c square minus 4c minus 1 equal to 0. So now c is going to be minus b. So minus minus 4 plus or minus square root of b square is 16 minus 4ac is minus into minus 1 plus by 2a, that is 6. So c would be equal to 4 plus or minus square root of 16 plus 12 is 28 by 6, which is 4 by 6. If we take it, we get 2 by 3 plus or minus 28 can be written as 2 root 7 by 6. This again gets cancelled and we have 2 plus 3 plus or minus root 7 by 3. Okay, so that means we have got two values for C, but we have to look at the open interval -1, 2. So let's see, 2 by 3 plus root 7 by 3. So this belongs to -1, 2. Similarly, 2 by 3 minus root 7 by 3 belongs to -1, 2, the open interval. So therefore C is equal to 2 plus root 7 by 3 and 2 minus root 7 by 3. So after evaluating it, you get a mathematical answer. But we have to see whether it actually applies in the given context. So we have to check whether all the values of C that we have received or got, does it really fall into that interval? Okay, third one. Now f of x is equal to -2 sine x in the interval -pi pi. Okay, we know sine x is continuous throughout, so it is going to be continuous in -pi to pi closed interval. It is going to be differentiable in the open interval -pi to pi. And now we have to figure out the f of a, which is f of minus pi, which is equal to -2 sine minus pi, which is equal to -2, minus comes out, so plus sine pi, which is equal to sine pi is 0. Similarly, f of b is equal to f of pi, which is equal to -2 sine pi, which is again 0. So which means f of a is equal to f of b. So all the three conditions are satisfied. So therefore there exists C belonging to the interval -pi to pi such that f prime of C is equal to 0. So f prime of C is going to be -2 sine x. So derivative of sine is cos. So cos C is equal to 0, which implies cos C is equal to 0, which implies C is equal to, when is cos 0? In the interval, it is 0 at pi by 2 and it is also 0 at minus pi by 2, and both pi by 2 and minus pi by 2 are in the given interval of minus pi to pi. So therefore This is the set of values at which the tangent is going to be horizontal. Fourth one, f of x is equal to x square plus x minus 30 divided by x plus 7, and the interval given is minus 6 comma 5. Now here f of x is undefined at x plus 7 equal to 0, that is x equal to minus 7. But this minus 7 is not, does not belong to minus 6 comma 5, right? So therefore f of x is continuous in minus 6 comma 5, and which means it is differentiable in the open interval minus 6 comma 5. Now we have to see f of a, which is f of minus 6, which is minus 6 square plus minus 6 minus 30 by minus 6 plus 7. So here this is going to be 36 minus 6 minus 30 by 1, which is equal to 0. Similarly, let's look at f of b. So f of b is going to be f of 5. So 5 square plus 5 minus 30 divided by 5 plus 7, which is 5 square is 25, 25 plus 5 is 30, 30 minus 30 is 0. So the whole thing is 0. So f of a is equal to f of b. Therefore, there exists a point C belonging to the open interval minus 6 comma 5 such that f prime of C is equal to 0. Okay, which means we need to figure out f prime of C. So what is the function here? The function is x square plus x minus 30 by, so let me just write it off, x square plus x minus 30 by x plus 7. So instead of using x, let's use C. So we have C plus 7 derivative of the numerator, that gives us 2c plus 1 minus, okay, so that gives us derivative of the denominator times c square plus c minus 30 divided by c plus 7 square equal to 0, which implies, let's open up this, so 2c square plus c plus 14c plus 7 minus c square minus c plus 30 equal to 0. The denominator disappears when we take it to the other side, which implies c square, this plus c and minus c cancel, so plus 14c, then 30 plus 7, so 37 equal to 0. So now again let's use the quadratic formula, minus b plus or minus square root of b square is 14, 14 square is 196 minus 4 times a times c, so 4 times 37. Now 4 times 37 is 148 divided by 2a, which gives us minus 14 plus or minus square root of 48, 196 minus 148 divided by 2. Now if we split it, we get minus 7 plus or minus, now 48 is 16 times 3, 48. Square root of 16 is 4. So 4 root 3 by 2. So 2 2's, which gives us minus 7 plus or minus 2 root 3. Okay. Now this is a mathematical answer. Now we have to figure out which of these or both of them do they lie in the given interval. So let's quickly do that. Minus 7 plus 2 times 1.7. So minus 7 plus 2 times 1.7 gives us 7 2s 14, 1 2 ones to 3, 3.6. Okay, so this is in the given interval of minus 6 comma 5. It is between minus 6 and 5. Now what about the other one? Minus 7 minus 2.1.7, 2 times 1.7, which gives us minus 7 minus 3.4, which gives us minus 10.4, which is not in the given interval. So therefore C is equal to only single value, that is minus 7 plus 2 root 3. This is one additional activity you have to do to make sure that the resulting value is within the given interval, because we are interested only in that given. Okay, fifth one, y is equal to minus 2 cos x in the closed interval minus pi to pi. Okay, cos x is continuous throughout. So that means it is continuous in the closed interval minus pi to pi. It is differentiable in the open interval minus pi to pi. Now we have to figure out f of a is equal to f of minus pi, which is minus 2 cos minus pi, which is equal to minus 2 cos minus pi, pi. Minus 2 times minus 1, which is 2. Okay, f of b is equal to f of pi, which is equal to minus 2 cos pi, which is equal to 2. So which means f of a equal to f of b, and the conditions are satisfied. So therefore there exists C belonging to the open interval minus pi to pi, such that f prime of C is equal to 0. Okay, so let's differentiate. So f prime of C is equal to, remember this function is minus 2 cos x. So minus 2, the derivative of cos x is minus sign. So minus sign C times 1 of the x. So which gives us 2 sine C, which, and also we have to remember to put equal to 0. So which implies 2 sine C equal to 0, which implies sine C is equal to 0, which implies when is sine 0? When the angle is, which belongs to the open interval minus pi to pi. So here remember, it is not a closed interval we are talking of. We are talking of an open interval, because otherwise sine of pi is also 0, sine of minus pi is also 0. But in an open interval we don't include pi and minus pi. Look at the sixth one. F of x is equal to x square minus 16 by x plus 5 in the closed interval minus 4 comma 4. Okay, it's a rational function. Okay, not continuous at x plus 5 equal to 0, which is x equal to minus 5. But minus 5 does not belong to the interval minus 4 comma 4. So which means therefore continuous in minus 4 comma 4 is differentiable in open interval minus 4 comma 4. Now let's say see what is f of a. Now f of a is f of minus 4, which is equal to x square minus 16. So minus 4 square minus 16 by minus 4 plus 5, which gives us 16 minus 16 by 1, which is 0. Similarly, f of b is equal to f of 4, which is 4 square, which is 16 minus 16 by 4 plus 5, which is 0 again. So which means f of a is equal to f of b. Therefore, there exists C belonging to the open interval minus 4 comma 4 such that f prime of c equal to 0. Okay, now let's figure out that f prime of c. F prime of c is, remember we are talking of x square minus 16 by x plus 5. So we have to differentiate it. So c plus 5, wherever x is there, we use c. C plus 5 denominator as it is, then we have to differentiate the numerator 2c minus differentiate the denominator x square minus 16 divided by x, not x, c plus 5 square equal to 0. So which implies 2c square plus 10c minus x square plus 16 equal to 0. The denominator disappears when we take it to the other side. Yes, which implies 2c square minus c square. Oh, all this will be c. Okay, so 2c square minus c square is c square plus 10c plus 16 equal to 0. So c will be equal to minus b plus or minus square root of, let's solve for c. So c is equal to minus b, that is 10 plus or minus square root of b square, that is 100, minus 4ac. So 16 fours 64 divided by 2a. Okay, so this becomes minus 10 plus or minus square root of 36 by 2 is equal to minus 10 plus or minus 6 by 2, which is equal to minus 4 by 2, or the other solution is minus 16 by 2. Okay, so which gives us minus 2 and minus 8. But remember, we are looking at what interval? The open interval minus 4 comma 4. So here this is not in this interval. So our point of interest is minus 2. So that is the point or the value of x for which the tangent will be horizontal. Seventh one, y is equal to cos 2x in the closed interval minus pi to pi. Cos is continuous in the closed interval minus pi to pi, is differentiable in the open interval minus pi to pi. And now let's figure out f of a, which is f of minus pi, which is equal to cos minus 2 pi, right? Now, minus 2 pi means what? The same starting point itself. So, which is equal to 1. Now, f of b is equal to f of pi, which is equal to cos 2 pi. It is also the same point, so 1. So, therefore, f of a is equal to f of b, which implies, therefore, there exists c belonging to the open interval minus pi to pi such that f prime of c equal to 0. So f prime of c, that is cos 2x, is what? Cos 2c is what? It's going to be, cos is minus sine 2c times 2 equal to 0. So which implies minus 2 sine 2c equal to 0, which implies sine 2c equal to 0. Now this is the tricky part. When is sine 2c equal to 0? You can try to figure out when 2c is equal to. So when is it 0? It is 0 when the angle is 0, right? When it is pi, it is 0, and when it is minus pi, which means c is equal to what? 0 by 2, which is 0, pi by 2, and minus pi by 2, and all of them lie in the interval minus pi to pi. So therefore, C is equal to minus pi by 2, comma 0, comma pi by 2. So there are three values for which there will be a horizontal tangent or the slope will be 0 between these two interval points. Okay. Now let's look at eighth one. F of x is equal to sine of 2x. Again in the interval minus pi to pi. Now sine is continuous throughout. So it is going to be continuous in the closed interval minus pi to pi. It is differentiable in the open interval minus pi to pi. Now let's see f of a is equal to sine, no, not sine. Let's f of minus pi, which is equal to sine minus 2 pi, which is sine 2 pi, right? F of b is equal to f of pi, which is equal to sine of 2 pi. So therefore f of a is equal to f of b. Therefore there exists c belonging to the open interval minus pi to pi such that f prime of c is equal to 0. So let's look at f prime of c. Remember the function given to us is sine 2x. So when we differentiate it, we get cos. We are not going to use x, we are going to use c. So cos 2c times 2 equal to 0, which implies cos 2c equal to 0, which implies 2c is equal to. Now we have to figure out when is cos 0. So cos is 0 at pi by 2, which means it is going to be also 0 at minus pi by 2. Then it is also 0 at 3 pi by 4 and minus 3 by 4. Yes, it's a simple thing. You have, if you, it is 0 at this point, and if we keep going, it is again 0 at this point. So this is pi by 2, this is 3 pi by 4. But if you go in the opposite direction, this is pi minus pi by 2. And if you keep going, this is minus 3 pi by 4. So there are 4 points at which, okay, so that is for 2c. C would be equal to pi by 4 minus pi by 4, 3 pi by 4 and minus 3 pi by 4. So at these points, there are 4 points at which there will be a horizontal tangent to the curve between these two given interval points. Okay, so that is the 8th one. 9th one. Y is equal to, now instead of y, let's, okay, f of x is equal to minus x cube plus x square plus 4x minus 5. And the interval given to us is minus 2 comma. It's a polynomial, therefore it is continuous throughout, and specifically in this interval also it is continuous. It is differentiable in minus 2 comma 2. Now let's look at f of a, which is f of minus 2, which is equal to minus 2 cube is minus 8. So plus 8 plus minus 2 square is 4. Minus 2 times 4 is minus 8 minus 5, which gives us 4 minus 5 is minus 1. Now let's look at f of b, which is f of 2. Okay, this gives us minus 2 cube plus 2 square plus 4 times 2 minus 5, which gives us minus 8 plus 4 plus 8 minus 5. So 8 cancels, 4 minus 5 is minus 1. So which means f of a is equal to f of b. Therefore, there exists a c belonging to the interval minus 2 comma 2 such that f prime of c equal to 0. Now f prime of c minus x cube plus x square plus 2x 4x minus 5. So let's see. This would be, and we use c instead of x. So minus 3c square plus 2c plus 4 equal to 0. So now, which implies, now let's multiply it off by minus 1. So we get 3c square minus 2c minus 4 equal to 0. So which implies c is equal to minus b. So 2 plus or minus square root of b square is 4, 4ac. So 4 times 3 is 12, 12 4 is 48, minus into minus plus, so minus plus 48 divided by 2 times 3 is 6, which implies c is equal to 1 by 3 plus or minus. This is going to be 52 by 6, which is equal to 1 by 3 plus or minus. 52 can be written as 13 fours 52. So 2 root 13 by 6. So 2 threes, which gives us 1 by 3 plus or minus uh, root 13 by 3. Now, so we have two values. Again, we need to check whether both the values are there in the given interval. You can use the calculator to quickly figure it out. So you will realize that both the values are within the interval. So we can write it as 1 plus or minus root 13 by 3. Okay. Now let's look at the 10th one. Y is equal to f of x is equal to 2 sine x in the interval minus pi to pi. Sine is continuous in the interval minus pi to pi, is differentiable in the open interval minus pi to pi. F of a is equal to f of minus pi, which is equal to 2 sine minus pi, which is equal to 2 minus 2 sine pi. Okay, f of b is equal to f of pi, which is equal to 2 sine pi. Okay, so which is also 2 sine pi, but remember, even though negative positive is there, but sine pi itself is 0. So both of them are equal to 0. So therefore, f of a is equal to f of b. So therefore, there exists c in the given interval minus pi to pi such that f prime of c equal to 0. Now f prime of c of 2 sin x is going to be 2 times cos x times 1 equal to 0. That is cos x equal to 0, which implies x is going to be no, not x, c. Now for all, this is also c. Now, for what values of the angle will cos be 0? It is going to be minus pi by 2 and pi by 2. So that is the set of values at which the tangent will be horizontal. There has to be at least one value. That's what Rolle's theorem says. Now, 11th one, f of x is equal to minus 2 cos 2x in the interval minus pi to, we know cos is continuous in the closed interval minus pi to pi. It is differentiable in the open interval minus pi to pi. F of a is equal to f of minus pi, which is minus 2 cos minus 2 pi, which is equal to minus 2 pi basically means the complete circle, right? Which is 1, which is minus 2. Similarly, f of b is equal to f of pi, which is equal to minus 2 cos 2 pi, which is again minus 2 times 1, which is equal to minus 2. So again, f of a is equal to f of b. All the three conditions satisfied. Therefore, there exists c in the interval minus pi to pi such that f prime of c equal to 0. Now, f prime of c is going to be minus 2 cos 2x is the function. So minus 2 cos is minus sine 2c times 2, which gives us 4 sine 2c equal to 0. So this implies sine 2c is equal to 0, which implies 2c is going to be. So for what angles is it 0? It is 0 when it is 0. It is 0 when it is pi, and it is 0 when it is minus pi. So which implies c is equal to 0, pi by 2 and minus pi by 2. So these are the values for which that tangents will be horizontal or the slope will be 0. 12th one. F of x is equal to x square minus 36 by minus x plus 7 in the interval minus 6. Now, not continuous at minus x plus 7 equal to 0, which means minus x equal to minus 7, which means x equal to 7. But the 7 is not there in this interval. So therefore, f of x is continuous in the interval minus 6 to 6. It is differentiable in minus 6, 6. Now, let's see f of a is equal to f of minus 6, which is equal to, now here remember we have x square. So minus 6 square minus 36 by minus 6 plus 7, which gives us 36 minus 36, so 0. Similarly, f of b is equal to f of 6, which is equal to again 36 minus 36 by 6 plus 7, which is again 0. Which means f of a is equal to f of b. Therefore, there exists c belonging to the open interval minus 6 comma 6 such that f prime of c equal to 0. Okay. So f prime of c is equal to what? Now here the function that we were given is x square minus 36 by minus x plus 7. So let's differentiate it. We get minus c plus 7 denominator as it is. Then we have 2c minus 1. So plus 1 times c square minus 36 divided by minus c plus 7 square equal to 0, which implies this gives us minus 2c square plus 14c plus c square minus 36 equal to 0. This will disappear, denominator, which gives us minus c square plus 14c minus 36 equal to 0, which implies c square minus 14c plus 36 equal to 0. Okay. Now let's solve the quadratic formula. So c is equal to minus b plus or minus square root of b square is 196 minus 4ac. So 36 times 4 is 4 6 24 2 4 3 is 12 144 divided by, which gives us 7 plus or minus square root of 196 minus 144 is 52 by 2, which gives us 7 plus or minus 2 root 13 by, so 2 cancels and we have 7 plus or minus root. Which of these two values lies in the given interval? Minus 6 to 6. So 7 plus root 13 is, let's say 3.5, which gives us 10.5. So which means this doesn't belong to minus 6, 6. Whereas 7 minus 3.5 gives you 7 minus 3.5, 3.5, which belongs to minus 6, 6. This does not. So therefore, C is equal to 7 minus root 30. Therefore, one of the results we reject. That is the mathematical answer. This is the answer in the given context. 13th one. F of x is equal to minus x square minus 3x plus 18 divided by minus x plus 4 in the closed interval minus 6 comma 3. Now here denominator cannot be equal to 0, right? That means minus x cannot be equal to minus 4, which means x cannot be equal to 4. But this 4 does not belong to minus 6, 3, right? So therefore, f of x is continuous in minus 6, 3 interval. F of x is differentiable in the open interval minus 6, 3. Now let's very quickly look at f of a, which is f of minus 6, which is minus 6 square minus 3 times minus 6 plus 18 divided by minus 6 plus 4. So this comes to 36. So minus 36 plus 18 plus 18 divided by 2, minus 2, which is equal to 18 to 36. 36 minus 36 is 0. Now f of b is equal to f of 3, which is equal to minus 3 square minus 3 times 3 plus 18 divided by 3 plus 4, which gives us minus 9 plus 18 by 7. Minus 9 is minus 18 plus 18 is 0. So f of a is equal to f of b. Therefore, there exists c belonging to the open interval minus 6 comma 3 such that f prime of c equal to 0. Let's differentiate the function at c. So at c would be, the function itself is minus x square minus 3x plus 18 by minus x plus 4. Okay, so let's differentiate this. We get minus c plus 4 and then we get minus 2c minus 3 minus, and differentiating the denominator, times minus c square minus 3c plus 18 divided by minus c plus 4 square equal to 0. So now let's simplify. This will get will disappear when we take to the other side. So we would have minus into minus plus 2c square plus 3c minus 8c minus 12, minus into minus plus, so we can just blindly write this, c square minus 3c plus 18 equal to 0. Okay, so 3c and minus 3c cancels. 2c square minus c square is c square minus 8c. 18 minus 12 is plus 6 equal to 0. Okay, now let's put it as implies. Okay, so c is equal to quadratic equation minus b. So a plus or minus square root of b square is 64 minus 4ac. So 6 4 24. divided by 2, which gives us 8 plus or minus 64 minus 24 is 40 divided by 2, which is 8 by 2 is 4 plus or minus 40 can be written as 2 root 10 by 2. 2 cancels, so root 10. And again, if you look at the values using the calculator, you will notice that C equal to only the 4 minus root 10 would be the valid within the given interval. Okay, 14th one. F of x is equal to x square by 2 minus 4x plus 8 in the interval 3 comma 5. It's again a polynomial. So since it is a polynomial, it is continuous, it is differentiable, continuous in the closed interval 3 by 3 and 5 and open interval 3, 5. Now f of a is equal to f of 3, which is going to be 9 by 2 minus 4 3 is 12 plus 8, which is equal to 9 by 2 minus 4, which is 9 minus h is 1 by 2. F of b is equal to f of 5, which is going to be 5 square by 2. So 25 by 2, right? Minus 5 fours 20 plus 8, which gives us 25 by 2 minus 12, which gives us 25 minus 24 by 2, which is 1 by 2. So f of a is equal to f of b, which implies that there exists c belonging to the interval 3 comma 5 such that f prime of c equal to 0. So f prime of c is going to be, remember, this is x square by 2 minus 4x plus 8. So when we differentiate it at c, we get 2c by 2 minus 4 equal to 0, which implies c minus 4 equal to 0, which implies c is equal to 4. So there is only one value, and that is there in the given interval 3 to 5. Okay, 15th one. F of x equal to x square by 2 in the interval minus 1 to 1. It's a polynomial, so therefore continuous throughout, and it is differentiable, especially in that, since it is differentiable throughout, it is differentiable in this interval also. Now f of a is equal to f of minus 1, which is equal to minus 1 square by 2, which is 1 by 2. F of b is equal to f of 1, which is equal to 1 square by 2, which is 1 by 2. Now since f of a equal to f of b, therefore there exists c belonging to this interval of minus 1 comma 1 such that f prime of c equal to 0. Now f prime of c of x square by 2 is equal to 2c by 2 equal to 0, which implies c is equal to 0. So that's the only one value at which the tangent would be a horizontal line or the slope will be 0. 16th one. Y is equal to x square plus 3x minus 10 divided by minus x plus 3 in the closed interval minus 5 comma 2. Okay. Now we know that it is not continuous at minus x plus 3 equal to 0. That means minus x equal to minus 3, x equal to 3. But 3 doesn't belong to the in the interval 5 comma 2. Okay. So which means y is continuous in the closed interval minus 5 comma 2, It is differentiable in the open interval minus 5 comma 2, and now we have to figure out f of a. Now f of a is f of minus 5, which is equal to minus 5 square plus 3 times minus 5 minus 10 divided by minus 5 plus 3, which gives us 25 minus 15 minus 10 by minus 2, which is equal to 0. Okay. Similarly, f of b is equal to f of 2, which is equal to 2 square plus 3 times 2 minus 10 divided by minus 2 plus 3, which gives us 4 plus 6 minus 10 by 1, which is 0. So as we have seen, f of a is equal to f of b. Therefore, there exists c belonging to the interval minus 5 comma 2, such that f prime of c is equal to 0. So for the function x square plus 3x minus 10 by minus x plus 3, let's figure out what is f prime of c. So this would be minus c plus 3 as it is times 2c plus 3 minus minus 1 times c square plus 3c minus 10 divided by minus c plus 3 square is equal to 0. Okay, this will disappear when we take it to the other side, and what we get after simplifying this is minus 2c square minus 3c plus 6c plus 9. This 2 becomes plus, so we have plus c square plus 3c minus 10 equal to 0, which implies minus 3c plus 3c minus 2c square plus c square. So minus c square plus 6c minus 1 equal to 0. Okay, let's multiply it by minus 1. We get c square minus 6c plus 1 equal to 0. So c is equal to minus b plus or minus square root of b square minus 4ac, that is 4, divided by 2a. So this gives us 3 plus or minus square root of 32 by 2. Now square root of 32 is 16 to 32. So 3 plus or minus 4 root 2 by 2. So 2 2's cancel. So we are left with 3 plus or minus 2 root 2. Now the interval that we are interested in is minus 5 comma 2. So 3 plus 2 root 2 gives us 3 plus 2.2 times 1.7, now 1.414, which is equal to 3 plus 828.2, which gives us 5.828, which does not belong to minus 5 comma 2. Okay, since we are doing it, let's do it for 3 minus 2 root 2, 3 minus 2 times 1.414, which is equal to 3 minus 2.828, which gives us 0.17, is in the interval minus 5 comma 2. Therefore, the c that we are interested in is 3 minus 2 root 2. 17th one is f of x is equal to cosec, okay, in the interval minus pi by 4 to minus 3 pi by 4. Here a is at minus pi by 4, b is at minus 3 pi by 4. So which means uh, f of x is continuous in minus pi by 4 to minus 3 pi by 4, and it is differentiable in the open interval minus pi by 4 minus 3 pi by 4. Now let's figure out f of a, which is f of minus pi by 4, which is equal to cosec is 1 by sine minus pi by minus sine minus theta is minus sine theta. So minus 1 by sine pi by 4. Now sine pi by 4 is what? 1 by root 2, which gives us minus root 2. Right? Now f of b is equal to f of minus 3 pi by 4, which is equal to 1 by sine minus 3 pi by 4, which is minus 1 by sine 3 pi by 4, which is equal to minus 1 by sine 3 pi by 4 is again 1 by root 2, which is equal to minus root 2. So again, f of a is equal to f of b. It is continuous, it is differentiable, and f of a equal to f of b. So that means there exists c belonging to the interval minus pi by 4 and minus 3 pi by 4, such that f prime of c equal to 0. So f prime of c of cosec x is minus cot, here we are talking of c, so cot c cosec c equal to 0. So which means minus will disappear when it goes to the other side. So cot c is equal to 0 or cosec c is equal to 0. Cot c is cos c by sin c equal to 0, which means cos c equal to 0. Cos c equal to 0 when it is pi by 2 or minus pi by 2. Okay, this is 1 by sin c equal to 0. Now this doesn't work out because sin c goes to the other side, we have 1 equal to 0, so meaningless. So we ignore that. Now here it will also be equal to 0 when it is pi by 2, 3 pi by 4 and minus 3 pi by 4. So now we have got so many values. We are interested in what? We are interested in minus pi by 4 to minus 3 pi by 4. So out of this, how many of them are in this range? This is not, because these are positive, this interval is negative. So since it is the open interval, minus 3 pi by 4 is also not valid. So therefore, C is equal to minus pi by 18th one. Okay, f of x is equal to natural log of x square in the interval of 1 by 4 comma 4. Is it continuous? Natural log x is continuous, right? So natural log x is continuous throughout, which means it is also continuous in the interval 1 by 4 and 4. It is differentiable in the open interval 1 by 4 comma 4. Okay, f of a is equal to what? Natural log of 1 by 4 square. Now this can be written as natural log of 4 to the power of minus 1 square. Now this can be written as minus 1 natural log of 4 square, right? Which means natural log of 4 square. Now f of b is equal to natural log of 4 square, and these two are same. So which means f of a equal to f of b. That means there exists c belonging to the interval 1 by 4 and 4 such that f prime of c equal to 0. Okay, now let's differentiate with c, f prime of c. Now remember the function is natural log of x square. So which means when we differentiate it, we get 2 natural log of c times 1 by c times 1 for x. So that becomes 2 natural log of c by c. Now this should be equated to 0, right? Because of this. So which means this becomes 2 natural log of c equal to 0. Natural log of c equal to 0. That means c is equal to, when is natural log 0? For 1. So that is the only value at which you will have the tangent which is horizontal, or the slope is 0. So that's it. Bye.